So Data Commons, NIH has a huge history of promoting and helping research organizations across data sets. It's an outstanding effort by NIH. Data Commons started in 2004 as the NIH roadmap for medical research, and the Common Fund was enacted by the Congress in 2006. This outreaching goal of NIH Commons was to accelerate new biomedical discoveries. And as you can see here, starting from 2010, it had impact in open science data cloud. It had impact in protected data cloud from Bionimbus. In 2016, many aspects of layers were built on top of that. And 10 years, it took 10 years for essentially centralizing activities around data. And it's also a complex problem, right? Imagine you're running a project starting in November, let's say today. You have to find the data sets and then map it in the format you like, run some quality control, do the analysis, and then get an answer, a question, and iterate over the analysis to get an answer. It takes quite a large amount of time. Is there a way we can speed up the process? And that's what we try to accomplish in Tag.bio. So one of the ways we started looking into it is to look data as a product. So data is no longer, if you start imagining if data is no longer a static resident entity, then data product will actually represent a harmonized, decentralized application layer on top of disparate data sources. So it's no longer data sets in S3 or data set in any blob storage. It's actually an application layer just on top of that, such with a smart API that can present a clean, standardized model for application or data scientists to consume. So Tag.bio essentially as a platform is a data mesh in a box. It's a containerized mechanism. It uses microservices. It's distributed but connected. It has domain-specific data products. It can run in cloud-native mode, and with the integral data governance and collaboration into it. So bringing the analysis to the data is a key principle at which we operate. In real life, it happens is that when you have a set of data product, which is imagine a containerized format, you are sitting inside your VPC. You are connecting to a separate VPC via an Amazon private link, such that the data never goes out from the network itself. We are also working on what we call confidential computing, in which the data product or the server, which is serving as the data product, remains in a secure enclave. So imagine this enclave is sitting over a load balancer in a given customer area. It has encryption keys and attestation mechanism. That enclave or that particular data node can be shared, or at least the applications can be shared with another enclave, such that once given attestation, such that someone else can update it if they have a proper permission. This is a hardware level data processing. We also went into integrating FHIR formats with Amazon Health Lake. So Amazon Health Lake is a HIPAA compliant service. It creates a document reference as attached to the output, and that resource stores clinical entities like medication or conditions, anatomy, and things of that kind. So we interfaced Health Lake with the data node to derive insight or build analysis output. So here I'll give it to Mark to go through the demo.
So what I'm going to try and do is illustrate some of the points that Sanjay was making, but using the live demo. So the easiest thing to do to start to look at a data product is to start a new analysis. And what you can see here is that this is effectively a visual representation of the data mesh. So these are two example clinical trials, one from Pfizer, one from Roche. So if we go in and think about how we would use a data product, each tile here represents one. This comes from a publication in Nature. This is the one that Sanjay talked about earlier. But basically what you have is a reference where you could go and read about the data in this data product through clinicaltrials.gov. It's also published in Nature Medicine. So you can look at the data or review someone else's actions on it. And this is kind of interesting in terms of reproducibility of papers, reproducibility of publication, because what we do routinely is go and find a publication, extract the data, and then make it into a data product. And if we think about how would we look at the data at a glance, then what you can see here is a data overview, which is really a dashboard, a kind of mini dashboard view of the data held within the data product. All right, so you have the reference and you have the dashboard, and those are both nice summaries or references to how it was viewed. But the interesting thing about a data product is that you can go in and you can ask a question. And so when I ask a question, I basically fill out a form. And here there are some modular pieces of the form that are used again and again in the way that we ask questions. So I'm going to build a subset of the patients that are in this clinical trial. I can do that by defining their patient IDs, their demographics. What I mostly do is I go in and I look at the patients that came from both of the arms in the clinical trial. I can save and use that. I could name it as arms and save it. And so now what I've done is I built a subset of data from the data product that I can now use in my analysis. I can go in and I can add in different gene signatures I might want to cluster by. I can carry on and I can just fill out this form. What I'm using here, the app I clicked on, is a gene expression clustering app. It's called the UMAP. And that's all, that kind of trail is represented here, how I got here. And now, having made a functional subgroup from the data, I can run the protocol. And what you can see is that when I cluster them based on their gene expression, it's a fairly random assortment of participants in the trial. There's some outlying groups which we could probably investigate. All right, so that's the clicker side of things. If I come back to the home screen and I want to look at the developer side of things, then I would come over to here. I'd click basically Launch Developer Studio. I can also use this to run R methods, and here we go. This is the one I'm looking for. So I can run an R method against a data product. So this is the gene signature that I'm going to extract from the TCGA data product. That gene signature pulls out a table of data, effectively, a data frame, and then running an R method on that data frame allows me to create a heat map. You can work in this side of the UI to build apps or build basically the controlling part of an app. And then you can take this type of build and you can bring it back into the UI. And there's an example here where we use that same R method, but within the UI. And now I have some control over how I can create a subset of samples, which gene signatures I might want to run. So let's just do that. And then if I run the gene signature, and then I run the protocol. And so when it says running query method external, it's actually going out and taking the R method, and it's running that R method over the samples I selected, and it will generate a heat map that will look very much like the heat map that we just produced within the notebook, or we had produced within the notebook, because it's effectively running that same method, but now it's running it within the UI. And that's kind of the demonstration of how we think the platform really works optimally. Is you have the idea that data scientists are producing apps that can work on data products that have an intent. Those apps are reusable, replayable. They're usable by anyone who can basically click their way through a UI. And whenever you do anything, it's saved within your history. So as a data scientist, you have the ability to build things for people that they can then use in an environment which is fairly intuitive. This is available as a public demo. If you want to come and investigate it, I'll hand this back over to Sanjay, and he can take you through how you come and work with us, basically.
For NIH part, we are making Tag.bio available as part of the STRIDES program. Tag.bio is also available from AWS Marketplace, so in case you are not from NIH or your general researcher wants to use it. So datamesh is a new concept. It goes beyond data lake. Please try it out. Thank you so much for joining.